get started. Welcome to the Interop working group call. This is call number 12 in the series. We have a few presentations today and some good updates. So I will share the agenda in the chat. And if you're watching the recording, this is issue 1626 in the PM repo. Awesome. Well, starting off with Jacob and Boundless.
Yeah.
Nice.
Can everyone see my screen? Perfect. Yeah, thanks for having me on. Excited to chat about sort of like an effort, currently going on in the Boundless ecosystem to sort of help move more trustless interop forward. Who am I? My name's Jacob. I'm the product lead at Boundless, where we're sort of trying to democratize access to ZK infrastructure and just make it in general easier to use. I think we're all familiar with ZK at this point. It definitely hasn't been the easiest thing to use for the past 4 or 5 years, but we think we're making strides and hopefully making it more accessible. You might have seen us on Twitter. If you see berries, that's probably us. I apologize if it's overwhelming at times. But here's a quick diagram of what Boundless actually is. Boundless is a set of, just like on-chain, off-chain, and a novel cryptographic primitive that, again, just makes ZK infrastructure. Happy to chat offline more about people that are interested in using it, but don't want to get bogged down in all the details right now. Here's sort of where we are in our journey. We went to mainnet beta a few weeks ago, and a big focus for us was, we have this new piece of tech. We want to try to help solve an open problem instead of, just having people send sort of fake proofs to the market and whatnot. And we wanted to attack this problem, which I think this group is going to be really familiar with, right? It is really hard to read the state of Ethereum unless you're running a full node. In the past, this has forced people to use alternative solutions, which are not the most trustless. So, like multi-sigs, oracles. And then there have been some great attempts at, some light clients with this. So people have tried Helios, which is a good attempt. The economic security does not match that of Ethereum. And this is, sort of what we set out to do and solve. And we've had what I sort of refer to as the ZK syzygy occur. And first of all, if there's one thing to take away from this presentation, it is the word syzygy. It's an alignment of celestial bodies in 3D space. And we've had some great things happen over the past month. So we had, a new version of the R0 VM come out. It's now 5x faster. I'll give you a sneak peek. We might get a similar performance bump with V3, which we're planning on releasing in the upcoming months. The next is the Boundless market. What really is happening here is we're moving from on-demand AWS cost, which is what we've historically priced people at, to on-prem hardware, where these providers are now in regions of the world where electricity at times is even subsidized by the government, which we're seeing it's sort of insane, another probably magnitude in cost reduction. And the last and probably most important, and is now my favorite EIP ever, which is EIP 7549, which took attestations out of the sync committee, which then reduces the amount of signatures we have to validate when generating these proofs. And this was a 100x cost reduction for us, which we love. We thank anyone that worked on that. So the solution, right, that we sort of come up with here is what we're calling, formerly is the Signal Ethereum now. Originally it was called zCasper, but it's this full validity proof that an epoch has been finalized in Ethereum. We call it a full ZK consensus client. We're not running the full beacon chain client within the ZK VM. We're not doing the STFs. So it's really more of a full finality client. The reason why we say it's a full ZK consensus client is because you are, checking the full validator set. So you're having the same validator set that secures Ethereum, back these proofs as well. And the output of this program is you get that checkpoint block hash, and you are guaranteed that this is a checkpoint block hash at the end of 2 epochs, in which the epoch two epochs ago is finalized by that validator Ethereum set. The TLDR, right, we're just taking Casper finality gadget, running it inside of a zkVM, checking that the exits entries are being dealt with properly and updating that. The good thing here is, okay, you have this like block hash, and we have this other library that makes it really simple to interact with this. We have this library Steel, where it essentially makes it easy to run Solidity code. So we use Alloy, we transpile that EVM bytecode into RISC-V bytecode so we can run in our system. So now Solidity is obviously very good for interacting with on-chain state and doing Merkle proofs and like that. So you can sort of take that existing logic, ingest that verifiable block hash that we generated with zCasper, and then compute over that data. So in practice, this sort of looks like, okay, I'm going to take these proofs. I can take this block hash to any chain, regardless of an L2 or an alternative L1. Take that verifiable block hash and start computing over Ethereum state, not just over what that current block hash is, but we also have the ability to look back in time. So you can look back all the way to Dencun currently. You can look at events within these blocks as well. And you can do ranges. So you don't have to just look at one single block. You can sort of look at events over a range of blocks as well to sort of what I call endlessly compute over Ethereum state, regardless of where you are. And the cool thing here is that it doesn't stop at Ethereum. We wanted to start with Ethereum because it's been a long known pain point with some of our partners. To be honest, it's the hardest one to do, not from a cost perspective, but from a technical complexity perspective. I think we've all dealt with Ethereum consensus in the past. It's complicated. Big shout out to the multiple consensus teams we talked to. Big shout out to the multiple people at the EF that helped us in this process. But the good thing is going to an L2 can be actually much easier. You're confirming much less, right? You're like sort of just verifying that a sequencer on that L2 is signing off on blocks, and they're including it in the DA layer. And we've actually started to prove some more chains already. We just haven't publicly announced it yet, but we're hoping to make those available as well. And again, I think in the past, ZK has been more expensive, but we're just having this cascading compounding effect of improvements with, open markets and better software and, possibly like ASICs and FPGAs that even now to prove these rollups is not too bad. So this was a metric, we took in March, which is probably already outdated and I should update this. And, we're proving a base transaction for 1/100th of a cent. So it's starting to become economically feasible. And with the boundless market, we can sort of subsidize these costs for people to start using before. And sort of what we envision with all of this, I can answer questions at the end. So and sort of what we envision all this is, if you remember a few years ago, there was like sort of this Vitalik blog post around the proof singularity. Once we start proving a chain, we can sort of combine these proofs. And imagine, we're proving Arbitrum1 in Ethereum mainnet. We now have one proof that represents that state. And if you have that proof on OP mainnet, you can now start talking to both those chains in a trustless way just by reading this block hash. So we sort of prove a chain, and now you get outbound gateways to every other chain. So we think this, can lay the foundation for, more trustless interoperability. A bonus here is we can start to get sort of light clients for each chain, which we find interesting for wallet providers, less relevant to this group. But, if we paired this consensus proof and execution proof, technically you could verify this proof in the browser. You can actually do this on our website right now. And you're now, tracking that the Ethereum validator set is, honestly providing block hashes and whatnot, and can be safer for wallets possibly. So we think, with this, we reduce bridging cost by, not having to pay sort of like fees on multi-sigs and whatnot. We reduce trust because you're now trusting the validator set in our ZK system, to be fair, but not a small group of people. And we think we can start to open new applications, doing cross-chain queries and whatnot. Our commitment here is to maintain this fully working ZK client, to operationalize it which we're in the process of doing right now. We want to audit, maintain it. So even in the next fork, we will continue to work. And then we're actually going to try running it as a public good for as long as possible. We ran a little donation campaign and we raised over 900K USD to cover the proving cost. Cool thing is on the market right now, people just do them for free, which is really nice. And then we also have this additional, mainnet incentive that'll help subsidize proving as well. So, it's really hard to say how these costs will adjust over time. It is an open market. We don't control it, so I can't fix it or anything. But I think at this point, I'm willing to say that these proofs will be up and running for at least the next year. And that might be, just being underestimating everything. We're working with a great set of partners as well. Everyone on this list is interested in integrating it and supporting us. And we're pretty much open to working with anyone at this point. So if you want to, use this, I'm in this Interop group. Feel free to reach out to me. Happy to provide an API key and assistance in integrating this into anyone's protocols. Yeah, that's the presentation. I can start going through questions.
Chat or audio?
Yeah. So what are the latencies of the proofs? Great question. So currently, most of the latency at full tilt actually comes from the need to wait 12 minutes for an epoch to finalize. I am personally a huge fan of 3-slot finality for this purpose of improving that. That is just my opinion. I understand, there's trade-offs here. But that is actually most of the latency. The cool thing also is we're not actually proving bound on any giant proofs anymore. We're bound on execution. So the execution for this proof at max tilt takes about 12 to 15 minutes, but you can sort of start that before the epoch finalizes and whatnot. We do have a set of improvements coming that should greatly improve this. We're releasing a V3 really soon that gives like a 3x bump to the executor performance. And then Jordy, Bylina, and the Zisk team have done just phenomenal work around this, and we're huge fans of what they're doing around like getting this execution up to gigahertz essentially, which could reduce that 16 minutes of execution down to just a few. But yes, definitely is a trade-off with this approach of you need to wait the 12 minutes for the epoch to be finalized. And I understand that's
and another 15 minutes for the execution, or why don't you just execute continuously, generate traces, and then prove?
Yeah, so we can parallelize essentially. So it would be a 3 minutes. That feature is not it's in a PR right now. But yeah, great point. And it is a trade-off when using this stuff. What's the proving time for a 30 million gas Ethereum block on an H100? So with these proofs, we're really the gas of a block does not change anything because the 95% of the proving time just goes from checking the million validator keys. So the proofs, regardless of block size, are pretty similar. I think they fluctuate 1 to 2% up down right now in total cycle costs, but it's that. Thank you for the kind words, Hart. For the L2 proofs, that will then be dependent on execution size. Currently, we can do a batch of, maybe like, I think it's like 150 blocks on base right now is 20 billion cycles. So that would take 5 to 10 minutes. If you started reducing the batches, like let's say you just want to prove like one block that a transaction's occurred, that is probably getting around those real-time proving numbers that you're seeing around. So 8 to 10 seconds. We should have more clarity soon on what those actual numbers are. We actually just got our data center set up. We'd only been running stuff in the cloud, and we're hoping to post some numbers around that soon. What's the best? Yep, that's my Telegram. Feel free to reach out. Nice to see you again, Jim. Do you match old light client API, basically JSON RPC supported? We don't have any out of the box JSON RPC support. Right? What, like, how easy to migrate from Helios? Okay, so yeah. So we actually are working on this as well. So we have the proof and we have that audited and whatnot, and we're trying to get the times down right now. But we also are going to provide an EVM contract where you could sort of like set an anchor. You have to set like a trusted anchor, essentially, just right with any other light client. And then you'll just like upload those. If you are on a co-located chain of a boundless market, you actually don't even have to like verify the proof. You could just like call the auction where it's occurring. If it's on a chain that the boundless market is not on, which is not on many right now, you just have to grab the proof from the market and submit it yourself to the chain. So we're really trying to like, I mean, I'm a product person. We're really trying to like get the full out of the box solution. I'm also, completely open to feedback on other things that might be useful to make this more usable from you all. What's the latency for just the EVM? Oh, no, it answered. Dreams, shorter batch submissions. Yes, 100% aligned. Yeah. Any other questions? Sweet. Yeah, thank you guys. Again, this is really short. Happy to answer any other details. And again, we really just view this as a public good for the Ethereum ecosystem and wider. There's not really any like catch. You can see the proofs being generated on the market right now, and we just want to get it in the hands of as many people as possible. That's the dream around this.
This is great. Thanks so much, Jacob. Maybe we can have you back in a month or two for some updates on how things are going.
Yeah. And just reach out to me if there's any feedback or things that like might be interesting for people to use. I'm all ears to make it as easy as possible to use.
Awesome. Cool. Up next on the agenda, we have some updates on the Open Intents framework. Maybe we can start with Pepe if you're available.
I am. Hello, Josh. Thank you for the intro. So sadly, I don't have such a fancy presentation as Jacob. Sorry for that. I mean, that's the problems are going second, I guess. So I will assume a lot of you are already familiar with the OIF, the Open Intents framework, but just a quick summary is basically as a way to standardize intents to facilitate interaction between clients, solvers, and different people in the ecosystem in the space. So it's been going for a while. It's a public goods initiative as well, where different companies are collaborating. I see people in this call that I've been meeting and having conversations with in different groups. And I want to share a little bit on the current status and progress, because we are in a very pivotal point of the development. So first, we have been doing or suggesting some changes into the 7683 standard, which is basically optimizing for performance and completeness. So I'm not sure if anyone here or checking the recording is actively using this standard or similar ones, or are considering using this standard. So if you have a wallet or a cross-chain product, feel free to reach out, because we really want to check that all the changes we are doing are going towards like something practical and useful for everyone. So it's now your opportunity to really adapt things to make your life easier, and we want to make it happen. Aside from the standard itself, we are working on a set of tooling for the ecosystem. The main one, obviously, being the Solidity contracts as a reference implementation and as a core element in the ecosystem. We are already talking with partners that are interested in using these contracts, and therefore we've adapted them already to be very modular. So we are very confident in the capacity of the current architecture to scale to different use cases, from like cross-chain swaps, payments, any kind of specifically cross-chain utility can benefit from this. We are also working on some off-chain systems. The most clear one being a reference implementation of a solver. So very quick summary of what an intent is to be able to understand this. The user will say, I want to receive 100 USDC on Base by giving 100 USDT on Ethereum. So someone will pick that intent, fulfill it, and once that fulfillment is proven, then they will unlock the money deposited on the original chain. So there are different players in the space. Most of them participate in this forum. I see Li-Fi, we have Across, we have like more people in the space. But we are creating a baseline solver so that new chains, new ecosystems can onboard fully by like their own, cloning this, expanding in a modular way, and having a basic solver. We obviously aim at this being competitive and good, but it is not a direct kind of competition of taking out the different players in the space. The OIF is an open intents framework, and that means that it will empower everyone in the ecosystem. Along with that, that solver, we are also standardizing some APIs and building SDKs around it. APIs mainly now for off-chain components. So you probably caught up. If you want to send 100 USDT from Ethereum to 100 USDC on Base, there will be a fee somewhere. In order to get that fee, in order to understand what the different solvers are going to offer you, we are standardizing an API that can connect to those different solvers so that wallets and users don't have to be implementing 5 different interfaces for connecting to the different protocols, and rather have a unified one that is fully compatible with every single player. Along with this, obviously, when you get the quote, you will get several quotes and you will be able to submit that intent. We are also working on that along with status updates and more quality of life elements. When we are talking about all of this, we identified the clear need of some sort of aggregation service. So we are also working on an aggregator service that is fully off-chain to help applications communicate with all the different players in the ecosystem through this aggregator. This is fully optional, okay? Like I understand, because we internally have also had a lot of discussions about risk for centralization. This is a fully optional module. You can still connect to the solver or put your intents on chain. This is just a helper element for players in the space that may want to integrate more easily for their users. So as you can see, we are building in different areas. I will recommend and I will ask, if you are building in this ecosystem or if you are interested in participating, please reach out to Joshua, to Josh directly. He's coordinated a lot of things. We can get in touch, and the next couple of weeks are going to be pivotal. We do have a pretty good speed in terms of development and pretty high expectations for deliveries over the next couple of quarters. So if you want to join the party, feel free to reach out. We are super happy to collaborate with everyone in the space.
Thanks so much, Pepe. It's a great update. I think we have one of the other key OIF contributors in the room. Jim, if you're available, did you want to share anything?
Yeah, I mean, I think Pepe said it the best, so I won't kind of repeat it. But yeah, if anyone's interested in collaborating, I think we shared some details there, and we'll certainly refine the process. I think just like some more tactical updates on our side, we have been working on having the OIF support the finalized 7683 specification. So that's been a big effort for us. Want to make sure that that comes out of the box. And of course, we're adhering to standardized interfaces across the whole ecosystem. And then the second thing is that we are also working really deeply with the Wonderland team and on the Kohaku wallet. I know a big kind of requirement has been multi-chain inputs. So the ability to, if you have a similar asset on different chains, be able to express an intent that basically combines all of that. And I think that kind of solves the issue that I think we discussed a few months back around this like fanning out of assets. It's like if you have a home chain, but you start doing a bunch of intents on some other chains, you slowly start accumulating assets on a ton of other chains that maybe you don't want assets on, you know, at the, you know, in the finalized state. And so this is kind of just like a simple cleanup method to simplify that complexity. So that's something that we're working hard to add to the OIF because we know it's a huge potential UX problem in the future.
There's a question from Fabrice in the chat. Maybe, I guess I could try to answer, but maybe Pepe or Jim.
Yeah, let me open it. Is the plan for IF to support non-EVM chains from the get-go? Right now, for like the very first milestones, probably not, since the main implementations for the contracts are in Solidity, but we already have in the code base, I think, mostly inherited from DeFi oracles from like Bitcoin, for instance. So the standards, the concept is ready. If a player, or like in this case, if Coinbase were to be interested in non-EVMs, I'm pretty sure we can have the conversation to like adapt roadmaps, timelines, and priorities to accommodate for real world needs.
Pepe, I might also add to Fabrice's question. There would be a need to like create a 7683 standard for non-EVM too, like an SVM standard, which I think is a new thing. I don't think anyone's created like a standard across EVMs yet. So I'm excited to do that. I think it'd be fun. But yeah, Fabrice, I think there's something that should get done there, and it's very much on people's roadmap. It's just kind of a new thing too.
Yeah, just for reference, our aggregator implementation is using the cross-chain standard address. I don't remember the exact number of the standard, but it already is prepared for Bitcoin, Stellar, Cardano, other ecosystems, non-EVM based.
Cool. Okay. I think that was a solid update on the OIF. Unless there's anything else, we can keep on going. Next up, I think we have some words from T1.
Yeah, thank you so much, Josh. Thank you guys for having me again. I'm super happy we've just had Jacob from Boundless, because at T1 we are trying to also find a niche on the whole spectrum of trade-offs between like this super hardcore native interoperability and the full-on trust me bro models. This is I think basically in the same vein as Jacob's assumptions. Hey, how can we make dApps living on this one L2, maybe one that already exists, probably Base on or Arbitrum or Superchain or whatnot, talk to a dApp living on another L2 that already exists, and be realistic and pragmatic about it today, and not hoping that all of the big L2s adopt our fancy based and native roll-up architectures tomorrow. And so we try to bring that about in a slightly different manner, where we, instead of focusing on trustlessness with ZK, where we like I guess Boundless try and bring block hashes from different L2s into your home chain. We instead focus on this trade-off spectrum on being fast. And I guess nowadays, when you say fast, you can't really have this aspiration of waiting for finality from the perspective of DL1, that is the 12.8 minutes for an epoch finalization. If you want to have a real use case a la 7683, couple of seconds of delay for bringing stuff cross-chain. And so instead, at T1, we try and find a way of bringing about what I would call permissionless interoperability or opt-in free composability between existing L2s and the L1 via having some metrics of when do we deem a certain state in a certain contract on a certain chain as sufficiently finalized, and we expose that to some sort of shared infrastructure, cross-chain infrastructure. And this shared view, we aim to actually prove to the L1 in every L1 block. So the idea here is that if you're able to have your cross-chain infrastructure layer reorg together with the L1, if the L1 ever were to reorg, you don't need to wait for L1's finality to credit, for instance, deposits or to credit any events that you listen for on the L1 to your chain, because you know you will reorg, so it's fine. And so the only thing you still need to care about is proving to the L1 the thing that happened in your chain. And so we try and make this possible via using TEEs that actually are able to prove basis and arbitrums and optimisms state to the L1 in a matter of milliseconds rather than 15 minutes. And so, yeah, the whole idea is instead of the current infra situation where we have those different rollups and we can go via the L1 and have full-on native interop, but at the expense of waiting for hours, basically, or only being restricted to having solvers fill very application-specific intents. We want to create this layer that would have a view into other rollups and convince the L1 about its view of the other rollups. Now, yeah, what is interesting about this approach? I would say an interesting item is the how to make this secure. And so, of course, TEEs can be broken, and they will. And so you don't want to just have a TEE convince the L1 about Arbitrum state, right? Arbitrum holds a lot of TVL, and you want to enable your users to be able to tap into it without being bound by the security of an enclave. And so to that end, we came up with this idea of having different roles for people who are running maybe just a sequencing node that orders transactions and is crypto economically secured using something like AVS. And then there's a separate role just executing those blindly sequenced transactions that are, for instance, hey, bring me this Arbitrum contracts methods output for a given Arbitrum block into the cross-chain liquidity layer. And they would be doing this within a trusted execution environment, but in a way that's reproducible. So the critical item here, in order to actually be able to apply crypto economic security, is to know what the output is supposed to be in a deterministic manner, such that if someone breaks this determinism, they be able to be attributed this fault to, which enables you to slash them, for instance, so detect it after the fact. And this is unfortunately something you can't have with confidentiality, with using, for instance, TEEs for confidentiality, because leaking information is not attributable. But claiming that Arbitrum's smart contract ABC had this output at this block height is an attributable offense. And so this is a second role that you can envision where a crypto economic budget can be applied. And now your otherwise glass ceiling for security would be the stake. And so you don't want to be bound by that either. And so in this design, I propose a trade-off that kind of complements boundlesses, maybe, and that we only require as DKP of a state transition in the system once the value at risk approaches the crypto economic security budget. And so this enables the system to proceed under most circumstances and only every now and then require this like super strongly aggregated ZKP to reset the value at risk counter. And it would only need to be halted should some situation, some user require a very, very valuable set of transactions to happen very fast, one after the other. And so, yeah, this is the idea I wanted to present to you guys. Get your feedback, get your thinking, and my aspiration is to try and fill all of the potential niches on the trade-off spectrum and hopefully have something for every app's needs.
Just one quick question.
Any questions?
Yeah, sorry if I missed this. What is the next big milestone for you guys, if you're able to share?
Oh, yes. So the next big milestone for us is actually going to be bringing what we have live on testnet today, an ERC 7683 testnet that allows fillers to be repaid roughly in a matter of seconds rather than the otherwise common 1 hour-ish delay to mainnet. So bringing that to mainnet. And this is just a demo of what you can do with a primitive of this sort, where basically any developer may require that T1 bring any fact about any supported chain to their home chain. And so one way of using this primitive is to convince a 7683 escrow contract about the fact that a fill happened on the foreign chain, right? And then the second big milestone is gonna be expanding the use cases or like adding more use cases that in particular allow developers to require writes to happen in this asynchronous way, in this best effort way that is a fundamental barrier to not having a shared sequencer, but that seems, in my estimation, to be a good trade-off in terms of feasibility. Victor, you have your hand raised?
Yeah. Can you guys hear me? Okay, sure.
Yep.
Okay. Yeah, my question basically is like you mentioned the idea of requesting ZKP when the value kind of like at risk reaches some kind of crypto economic security budget threshold. What I was thinking about there is, in addition to costs, which kind of are definitely non-trivial, but also kind of lower than we expected maybe a few years ago, there's the latency considerations as well, which are not, which I think the latency I'm really thinking about is kind of the one we talked about earlier, which is like if you want to read from Ethereum L1 and you want to use a ZKP to do so, you don't really have a way to do so until you wait for a finality, or maybe you accept a smaller subset of the consensus set, like a smaller subset of attestations, but then you don't get the same security guarantees. Basically, the consensus itself has a latency that seems like it would be going beyond the thresholds that you're trying to achieve with your architecture. Have you been like? I guess what are your thoughts on that? Sorry, I didn't. But for me as a question.
Yeah, excellent. So let me paraphrase if I got it correctly. Maybe you can have this like fast interop with the L1, but you will be bound by the fact that the L1 needs finality because otherwise it could reorg. Is this a part of the question?
the most fundamental part of it as well, which obviously you discussed addressing that by the idea of having the L2 reorg with the L1. And I guess I'm curious what your thoughts about how that plays with the kind of ZK as needed way of doing things.
Yeah. Okay. I see. Yes. So, how we treat reorgs, we reorg together with the L1. So that's taken care of. Doesn't work for the real life, but it works for chains. How this is compatible with on-demand ZKP is in the nature of this variant of a kind of multi-prover system. I'm not suggesting an architecture like Vitalik and Nethermind and Surge and Tycho people are suggesting when it comes to combining TE and ZK to mean, hey, we need some quorum so that we deem what they say as true. Instead, what I'm suggesting is we trust the TEE, and to be precise, we trust the quorum of restaked towards the TEE enabled AVS up until what the restaked slashable stake is. And as the system detects that the statements made based on this trust level are becoming so valuable in aggregate that they would soon exceed the crypto economic budget beneath it, the system would incentivize market participants to voluntarily also submit a ZKP on top. And if the ZKP ever is submitted, it would reset the value at risk to 0. And it may never be submitted, at which point I think the situation you might be having in mind would happen where the system would need to halt in order not to exceed the crypto economic security. So the idea TLDR is let us only require a ZKP when needed. When needed is based on a crypto economic calculation. And we try to make it rare.
Yeah, and that makes sense. I think the core of my question may be like, it's not clear to me what that ZKP attests to. So for example, like in the boundless case, we're talking about that basically with the signal attesting to the finality gadget going through. So the Casper finality gadget is what we're running. Versus in this case, if you haven't reached finality yet, it's unclear to me what you would use ZK to attest to.
I think Josh might be signaling we have 3 more speakers to go, but I would love to take this offline. Please hit me up on my Telegram or my Twitter. I put both links in the chat. Thank you, guys.
Thanks. Yeah, sorry to cut you guys short. Cool. Up next, we have route scan and interoperable addresses, aka chain-specific addresses. Hey, Jack. Ooh, you're muted if you're talking.
Oh, yeah, sorry, can you hear me? Okay. Can you see my screen?
Perfect.
Yep.
Okay. Yes, so we as block explorers, we are heavily focused on like and watching how the the Ethereum Interop is going forward. And also we've had a lot of issues in general when it comes to indexing more and more chains, especially under a unified interface, which we have. There were some issues that I also, commented on the specific, on some specific ERC that's been added or that's been, merged as a draft. And so I thought the best idea would be to actually, get in and dive deep onto some ERCs to give our feedback, and so that the ERCs are aligned not only to wallets, SDKs, and infra providers like RPC providers, but also for block explorers that need to ultimately show analysts, users, and developers what's happening and help them debug. So after
Sorry,
going to
Jack, just
Interopolis.
real quick,
Yep.
I think you might need to adjust your screen placement. It's kind of cut off right now.
Oh,
I can only see half of your screen.
better now?
No, maybe.
And maybe make it full screen or something. It's because your screen is huge.
There we go. Okay, this is better. It's still small,
Okay.
not full screen, but this is better.
Let me see. Let me try and change it. Oh, yes. Can you hear? Can you see now better?
Yep.
I don't know why it was simply sharing the whole screen. Okay, so so as I was saying, we're actually looking at many ERCs that account for interoperable addresses, cross-chain addresses, and I believe the most one, the biggest one that I believe is not considered or valued as much as we block explorers want to is ERC 7785, that it's on-chain identifiers for chain IDs, and so right now we're trying to understand how to make it interact with all the other ERCs, especially ERC 7786 about the standard format for cross-chain messages, and the idea would actually be to establish the best way to unify the interface of the 7786 that is now being merged a few days ago, I believe, with what is currently the draft being added of the ERC 7785. And the main issue about this discrepancy is that 7786 takes into account that there's a simple nomenclature and definition given to chains like arbitrum.eth, for example, but there's no way of classifying those chains. So if I want to send Josh 1 ETH from OP mainnet to Arbitrum, let's say, I can say josh.eth at Arbitrum to send it to Josh in a human readable manner, and that's what 7786 and 7930 talk about. But what it isn't talked about and it isn't discussed and described in the specifics is actually what is the second part of the address. So we all know that interoperable addresses need to be we need to have a specific routing for different chains, and we need to know how to choose between, for example, which USDC we need to choose from an array of possible USDC that I have on my wallet, and of course we need also to account for the fact that the destination address and the destination chains need to be clear from the user side or wallet side. But, and so this 7786 and 7930 solve most of these problems. But the thing is, we have a chance through 7785 of solving, I don't necessarily mean solving, but solidifying what is now a very precarious method of classifying EVM chains and possibly beyond EVM. Because right now, the classification of chains, like which chain ID do I have, which RPC and block explorer link, is maintained through a GitHub repo that it's not actively maintained, but it's just open for maintenance when a new chain comes in and adds a PR using their data. And instead, we have a chance through 7785 to actually use ENS or a specific naming, maybe a generic naming service to create an object of a chain. Because an object of a chain has their RPCs, its RPCs has a name, a chain ID, some other genetic identifications that can be non-EVM or EVM. It can have like a specific attestation that solves to how many block explorers are there, and it solves to how many RPC providers, what's their name, and all kinds of stuff that right now through 7786 and 7930 is not discussed, because it's simply a 7930 is simply a chance to say Arbitrum is this trinity, and that's it. But 7785 is actually could be seen as a dictionary for chains. And when it comes to EVM adoption, and we've been struggling with this, because we've for the past 6 months we've been working on the state of the market report by accounting for how many developers are developing how many chains. Josh, you have a question?
Yeah, sorry to interrupt, and yeah, sorry to be
Yeah, no.
But I just wanted to just wanted to flag that maybe we only have 1 or 2 minutes left for this. So if you wanted to get to another part of
Yeah.
the presentation,
It's just it's not specifically like this is just the article, and of course you can see this in the link that is being shared within the agenda. But the main idea is for us as RouteScan to start to champion 7785, so it can really be like this dictionary of chains that can then be used by any provider. It can also be used to do heavy research about like what's actually the state of EVM chains being developed and what is actually the EVM adoption. That's now a open question, I believe. So thank you.
Thanks, Jack. That was a great overview, much appreciated, and is a good segue to what we're going to talk about next. And we may have time for questions at the end, but yes, we have the Unruggable team here, as well as Wonderland, but maybe we can start with Unruggable on their work on the 7828 resolver. And yeah, apologies, we don't have a lot of time, but let's see what we can get to.
Hey everyone, my name is Martin from Unruggable. We're an independent R&D firm within ENS. And the work we're presenting today is part of our research, our Interop research, with a specific focus in ENS-based identity. So I am here to talk about EIP 7828. Just going to share my screen. Just a second, sorry. Are you able to see my screen?
Yep, we can.
Oh, good, awesome. So I think I'm going to skip most of this because it's been covered in the previous presentations. But yeah, basically EIP 7828 introduces a chain-specific human readable addresses. And this is powered by ENS IP11 and ERC 2304, which basically allow you to resolve a certain identity to a specific chain that is, Vitalik.eth on the base chain. And this spec is powered by ENS infrastructure. So what the resolver really does here is that it works with the coin types that have been specified by ENS. ENS IP11, that is for EVM chains, and BIP 44 constants for non-EVM chains, to get such coin types, that is For example, Ethereum, you'd get a 60 and Polygon 966, and you'd supply this along with an ENS identity like Vitalik.eth to resolve this person's specific chain identity. So what I wanted to present today was the resolver. We have the ENS 7828 resolver that we've built, and it's basically a library that allows you to visualize and just play around with valid 7828 addresses. And it works with a centralized chain list repo at the moment to resolve these addresses. And at the moment, it's compliant with the spec. And yeah, what we really need at the moment, I guess the ask coming into this was to find people to collaborate on this with, along with 7785 as we move 7828 from a centralized registry, that's chain list, to having a decentralized registry. So if you want to have a look at, the spec, play around, resolve some names, see how it works, feel free to just visit the repo and yeah, contribute and yeah, open any issues you find as well. And we're looking forward to any collaboration with some of the guys on the call, RouteScan and Wonderland, to work on these initiatives, which are really just quite important to the Interop roadmap. I'll stop there. Thank you.
Thanks so much. So we only have 2 minutes left. I think we have the Axel team here, Axel. But if yeah, we can spend a minute or two here, or we can wait until the next call. Maybe I'll leave it to you, Ash, if you're.
Yeah, we could do a super quick thing now, and maybe we could dive more into the tech on the next call. But we could just do a quick demo thing right now.
Yeah, that'd be great.
Cool. Hey everyone, yeah, Ash from Axel, building stablecoin savings accounts, super consumer facing, and love all of this tech. We did a lot of stuff with Intense over the past few months and recognize a lot of the people here. I'm gonna shut up, and then we have Dev on our team who can do a super quick demo and talk through it. Lots of stuff with TEs, lots of stuff with 7683, why 7702 wallets are better than smart accounts, stuff like that.
Hey Ash. Yeah, thanks. So yeah, we were using 7702 wallets using Alchemy to batch all transactions together. For our previous product, we were initially using sequential processing and also EOAs. So we had to take account of all the gas. So this was the most convenient thing for us. So I'm currently into these positions. I'm going to just withdraw, and we're seeing transaction times of 300 milliseconds end to end. So I can already go to the block processor, and I know that these have gone through. Additionally, the volume that we can transfer through this architecture is beyond insane. We deposited around 100K USDC, and it cost us 1 cent for the entire process. This is in conjunction with our belief that every user should be able to export their wallets. I don't think you'll be able to see this, but we can export private keys, and users will have access to all of these pools. So if they go to Morpho's website and log in through the wallet that they export through us, they'll be able to do anything that they want to with their wallet. And the way we're detecting wallet balances is we're parsing all ERC20 and ERC4626 logs, so that we make sure that all these actions, even if they happen not on our platform, are caught, and we'll have an accurate depiction of the user's current status. So yeah, this is honestly like insanely fast. We were surprised by it, and I think we can handle up to at least a few thousand users in concurrency if you want to if when we did our stress testing. So yeah, that's all.
Perfect, thanks. If you want to drop your contact information in the chat, and people can follow up with you async. Thanks so much, everybody, for joining. See you next time.
Thank you. Bye-bye.
Thank you, guys. Enjoy. Bye-bye.